Hello YouTube, this is Alexander again. Today you have a lot of power supply in front of you, and they are fixed power supply. You cannot use this kind of power supply on any purpose you want. Why? Because sometimes you need a special voltage for your device, and it's not very easy to find any voltage you want with this kind of power adapter. So the main thing here is when you have the concern to find this kind of power supply, you need to have the good voltage, mainly the good voltage, because sometimes you have enough current to feed your devices. So for example, if I want to add a plug to this radio, needs 6 volts in entry in this outlet here, and it's very hard to find exactly the good voltage for your devices. This is one of the main problems you can find with this kind of power supply. The other stuff is that sometimes the power supply like this are mainly switched power supply. That means it have a lot of noise on the output, which can provide some disturb on the device. For example, and this is why I present to you this radio. To talk about this radio, if I fit the outlet here with a noisy power supply, the radio doesn't work properly. It have a lot of parasites on the speaker, and it have a lot of difficulty to find some radio station on automatic mode. This is because the power supply you're fitting your radio is noisy, and it disturb the radio control on this unit. So what I want to talk to you about here is to talk about mainly the most case you can find around you, because you can find some stuff like this coming from flower market or some supermarket or anything you want. My purpose here is to test the noise of different power supply to see if there is a difference between cheap power supply or expensive power supply, or for charger adapter, because charger doesn't mean it's DC adapter, because the purpose is not the same. And of course, what I want to do here is to try to find a mean to change the voltage of those devices to fit completely your needs. For example, I have my scope here which needs exactly 70 volts, and to have 70 volts it's very hard to find this plug. So of course you can fit your devices with 50, because you need 17 volts. You cannot exactly fit your your devices with this kind of device which are only 15 volts. So what I made is, for example, I take this very good and very nice unit with a high quality brand. I don't know exactly this brand, but when you see the stamp here and the quality of made, you can see this one is a very nice made. It's very dangerous here. You have the means here coming from this box. So I dismounted this one, and I add a little LED to showing that this unit is working, and a little potentiometer here. This is exactly the same potentiometer you can find on this PCB, for example. The goal is to find the good point on the PCB inside, to find the good resistor to change to increase or decrease the voltage, to fit completely and to transform this power supply to a perfect power supply for your devices. So what I want to show you here is some different brand and some different voltage coming from anywhere. So for example, you have this one, which is a 5 volt 4 amps adapter. This one is broken because the capacitor at the output are dead. It's you need simply to change the capacitor. Sometimes these power supply are very easy to repair, sometimes they are not so easy, but anyway, this one is a very good quality brand. This is an industrial brand made for some informatic room, also calculating room, some devices like this, and they are very good quality because when you open it and you see the build of this kind of unit, you can see a very nice made. And of course, in this unit you will find this PCB. This PCB was repaired by me, of course, and if you see in the back of the PCB, you can see here a little resistor. This little resistor helps this device to go to 6 volt instead to have only 5 volts. If I want to supply my radio with this device, it's perfectly the good voltage, because this radio needs here 6 volt for to fit the circuit of entry. So after this little hack, if you can call it a little hack, of course, you can see this resistor soldered on this very microscopic resistor, which increased the voltage by 1 volt. And despite this fact, the power of this unit on the output is very nice and doesn't change at all. And so you can see here the good made of this PCB, very nice made in front or in the back. This is very good quality because this is industrial adapter. So in the same case, I have this PCB, which is hacked by me, if we call it hack, of course. This device was a very nice quality 12 volt device, and for my purpose I need 17 volts output, and this is what I made by soldering a sharp resistor here, which increase the voltage output by 5 until they reach 17 volts. And I try to make this one to supply my scope, but so this little plug is very powerful, and I think it's not worth to have so much powerful devices just for a scope. So this is the reason why I found this one on the flare market. This is 50 volts here, and I dismount it and try to find the good resistor to increase or decrease to have the good value at the output. As you can see, I put this little potentiometer here to give the abilities to this power supply to change his voltage on output, and so it's easy now to have a chosen voltage between random of 5 or 23 volts just by turning this little potentiometer like that. And of course this potentiometer is connected to a little resistor chosen specially for this purpose, and so it's worked very nice, as I'm going to show you now. As you can see on this little passive load, you can see a voltage here, but this is not the exact voltage. This voltage is the voltage of the resistance output to supply anything you want with these things. And as you can see, if I turn the little potentiometer I made specially for that, you can see you can adjust your voltage output for the purpose you want until Sometimes it's depend about the impedance of your potentiometer. This potentiometer is a 20 kilo ohm, and of course you can put more or less. By changing the range of your potentiometer, you can change easily the range of your output signal, but in fact this is not recommended by this little hack. After this modification, this power supply seems to be very stable, as you can see here. This is the voltage, or the new voltage arcade output, and you can see the current growing, and it's very stable. To experiment with these power supplies, I have this little board which is compounded by a little resistor of 22 ohms. This resistor is changeable to have a changeable output to feed any devices you want with an external power supply coming from this outlet. And you have here mainly some filter like a capacitor and a coil, which are connected or disconnected by this switch here. This switch is made to connect or disconnect the coil, and this switch here is made to connect or disconnect the capacitors. Of course, it's possible to connect them in the same time or separately to see any changement on the signal on the scope. This little LED voltmeter is made to read the voltage between the 2 points here of the resistor to choose the good value you need to feed anything you want anything you want to output from the entry here. And here you have two probes where you can connect the probe of your scope to show the signals on the scope. As you can see, you have this voltmeter connected through this board, and you have this supply which was modified to have variable output. And here you can see the little potentiometer which I'm going to turn, and you can see the voltage decreasing or increasing. Okay, the limit of this potentiometer, the lowest voltage you can have is 8 volt, and by turning to the other sense you will have the maximal voltage, which can be something 90 volts. 19. So to see the main thing, in fact, this kind of adjusting is not made to have a variable power supply. This is just to adjust your output to fit correctly the device you're working with. Okay, for me, I want it to stay like this, because this is what I need for my scope. Just between parentheses here, I have just put this LED to show them this device is working, and on the plug I have put this little shrink to enhance this connector, and of course I put a little LED to show you then your device is plugged to the main. So to help you to make this purpose, you need to have a 5K or 10K resistor, something like this, and you need to unbend the leads like this for to help you. This is the most quick way to help you to arc your little power supply, and just to bend, and you need to put the leads like that. Okay. Okay, here you have now the resistor you need for to make your investigation on your PCB, and with a little plier like this one, with which is a chirurgical plier. Take your resistor here. This is a surgery plier, and so you will have here the secondary of your PCB. You absolutely not have to work on the primary on your secondary, on your supply. With your resistor at your hand, you need to plug your charger and your device, your adapter, and to put a voltmeter on the output and see like this when the voltage will increase or decrease. You have to do it with a 5K or 10K resistor for not to create any damage, or but to do it in safety, if I can tell this like that. And this one, instead to give 15 volts, it give 17 volts, and it's work very nice. First, let's try this power supply made by Artisan for Yokogawa. It's a very high quality brand. This device was not open, and it's always closed, not modified. And this one is the PCB which is in this box. And of course, to make the modification, you just need to desolder this Zener diode, because this Zener diode is here for to protect any over voltage. And if you don't desolder this diode, you will have a short circuit when you will searching for the good resistor you need to change for to have more voltage. What I need to tell about that is this device was modifying for to give 17 volts from 12 volts, which is too much. In fact, it's better if you take a power supply giving 15 volts and you modify it for to have 17 volts. This one is 70 volts, but from 12 volt power supply, which is not the best idea, but okay, that works, but in not very stable at so much voltage value. So if you want to make this modifying, always choose the most close power supply from your purpose. So let's try this first. As you can see, it's quite nice and very quiet noise. That's not so bad. The second part here is the Condor power supply. This is a very high quality power supply, despite the fact that it's come from China and it's made from on China. So as you can see here, this is a National Instruments Japan Corporation, but here it's made in China. Okay, so this one give 15 volts for 2 amps, and this is exactly the same PCB there is inside, because this is another one. And here you can see the little modifier here. It's a very little CMS component changed for to have 17 volts, sorry, and this device works very nice. As you can see, the Condor is very clean. The wave you can see here is just the fan of the resistor which provides this little wave. If I put my finger on the fins, okay, you can see here the Condor is very clean. This is a modified to 15 to 17 volt Condor power supply, and you can see for 200 millivolts the output is very clean, and you have just this wave coming from the fan of the testing board. So it's very nice. It's very nice. The modification doesn't add any trouble on the quality of the noise adding. As you can see in this supply it's coming from the shop RS component, and I think this is American RS because it's switch mode power supply. It's American, I think, and we are going to see how much noise it have inside. Here you can see the RS power supply coming from RS manufacturer, and you can see the noise coming from this device. It's a very huge noise because each line here is 1 volt per 1 volt per division, and you can see there is the noise is very important on the device. On the passive load you have some filtering. I'm going to test if I can make soft the noise by adding little capacitor, barely better. And if I put a coil in the line, not really better, so I'm going to remove the coil and remove the capacitor, and you can see this ripple is very important, and it can disturb your devices. You can see here, this is a old model of power supply for Freebox or for Livebox, I don't know exactly, and it's made by Sagem, and we're going to see how much noise there is inside. Here you can see a noise coming from Sagem power supply. It's a device coming from Livebox or old Freebox, and you can see here the ripple is just about something like 20 millivolt, which is not so bad. I think for comparing to another power supply, this result is not so bad. This is a notebook charger coming from a laptop computer, and we're going to see how much noise there is inside. You can see here, without changing the setting of the scope, then the supply of the notebook is very noisy. So this is a battery charger, but you can also use this the adapter when your notebook is empty for working. In the same time it's charging your battery, and you can see the peak of the noise is very important here. This power adapter is made by Hewlett-Packard, and we can think then this power supply is not good. In fact, the output is corresponding not to an adapter, DC adapter power supply, but just for charging batteries. And for charging batteries you don't need a very nice filtering output. I'm going to show you this. This is the Hewlett-Packard adapter, and you can see the ripple of this adapter, which is very impressive, because in fact this device is not a power supply, it's just a charger, and the charger are not have not the same requirements than a power supply. Charger can be used for charging batteries even if the output is not very clean. This charger, so this is a charger and not a DC adapter, is not able to feed any device you have. And this is my first power supply for my scope meter, which I purchased it from AliExpress for not expensive price. It's worked very nice, I thought. And of course, when you're searching for noise on your scope, you will have lots of noise with this device, which is able to give you some parasites on your scope when the probe is disconnected, which is not very convenient, I think. And this is the new one I made. This one is a very nice brand, OEM. I think it's a nice brand because it's very nice made inside, not like this one, which are very sparse component inside. And this one have a LED made by me, and the little potentiometer for to increase or decrease your output. And we are going to see between them which are the best comparing to the noise output. Now let's try my first DC adapter for my scope and see how the ripple is. This is how the ripple is coming from my DC power supply I made for my scope. This power supply was purchased on AliExpress for not expensive price. Until now it makes a great job for me, but in fact my requirement was changed, and I think this is not a good way for me to use this power supply anymore. As you can see, you have a very important noise tingled with alternative current. I don't know exactly where this alternative current come from, because the alternative here is not exactly the same than the main, and you have here frequencies and over 10 Hertz, okay, but I don't really understand where this maybe the switch regulation process. It works by a little package of regulation. Maybe it's the reason why it makes this very high to ripple. And finally, this is not a very good deal to use this power supply. Now let's try this power supply. It comes from a fly market, and I open it to make a little modification inside with a little potentiometer for to increase or decrease when I want the voltage, and I replace the last plug by a lightning one, and see how it works. And you can see the signal is very quiet, not so bad, and in fact you can see a very little ripple. Don't know where the trigger is. Okay, you can see it's a very little ripple, something like 50 millivolts here. And it's for me it's enough to have a good behavior on my scope. And if I play with my board by adding a little capacitor, you can see the ripple is totally disappearing just by adding a little capacitor on the screen. You can see here. And so this is a very good result for me. And if you see this line coming very quickly vertically on the line, it's just coming from the fan. If I block the fan with my finger, you can see to have a very nice waveform waveform. It's a little noise, but it's a very little, and it doesn't disturb your equipment for working properly. Okay, this is the end of this kind of test. This is a new video. I just want to attract your attention of about one fact. For to make this experiment, I use a transformer which protects me about from the phase coming from the main, and it's very important to be very prudent with this kind of devices, because there is a high voltage, and if you are able to work on this kind of high voltage, be very careful, because this is not a game. I just have enough experiment to be very careful with this, and so if you have to work with this kind of stuff, please be very careful, because main voltage is very dangerous. So it appears like I use it with a very easy way, but in fact not. This is not so easy way. I have just here very close to my finger 8 voltage, despite the fact that this voltage comes from a protective box like this one. It's just make disappear the phase coming from the main, but there is always 230 volts here, and it's very dangerous, despite the fact there is this protective box. High voltage is very dangerous, and so if you want to make this experiment, be very careful. Use protective carpet like I do. If you have protective gloves, use these gloves for make your research, and of course your safety glasses if you have, because you never know when an explosion can occur and can burn your eyes. Of course, this kind of experiment on main voltage are very dangerous, and so please keep your safety before to do anything with that. Thank you for watching, and see you soon.